Good afternoon, everyone. I am Hamza Zulfiqar from Nanotech Lab, Information Technology University, Lahore, Pakistan. I am here to present my poster titled Paper-Based Electronics, Passive Components and Low-Pass Filters Using Solvent-Free Eco-Friendly Fabrication. We demonstrated two different passive components as resistors and capacitors. Then we fabricated them in series as RC circuits. Then use them in series as RC and demonstrate the low pass filter circuits. So for resistors, we use the pencil and paper based fabrication process using different graphite to create content pencils. We demonstrated the resistance values from 4 kilo ohms to mega ohms by using different graphite to clay content pencils as 8B, 4B, 2B, and 8B. So, uh, as the graphite to clay content pencil is the highest, the resistance achieved would be the lowest. So you can easily see that in this from this graph, as the graphite to clay content ratio of pencil is 90% and the resistance is the lowest. So using different graphite to clay content pencils, we achieved the resistance from the lowest value as 4 ohms and highest value in several mega ohms. After the successful fabrication of resistors, we fabricated capacitors using two different schemes as parallel plates and interdigitated capacitors. So for the parallel plate capacitors, we explored three conductive materials with four different substrate materials. We fabricated the parallel plate capacitors using the pencil and paper based fabrication process as well as the cut paste fabrication process. So using the combination of three different conductive materials with the four different substrate materials gave us the capacitance range from 2 picofarads to 10 microfarad. Also, the lowest values as 2 picofarad were achieved using the interdigitated capacitor scheme. So from this figure, you can easily see that the fabricated capacitance of different conductive materials with different substrate materials is different. So after as the resistors and capacitors are fabricated independently, then we fabricate them in series as R and C as low pass filters. We applied the input across the R and C and acquired the output from the capacitor. The input and output waveforms of the 600 kilohertz low pass filter circuits is shown in this figure. You can easily see that the sample of input and output waveforms of 600 kilohertz low pass filter at 100 hertz, 100 kilohertz, 600 kilohertz, and 1 megahertz. So 600 kilohertz is the cutoff frequency, and you can easily see that the output waveform in this figure is about 70.7% of the input. So in next figure, you can easily see that the measured and the calculated response of our 600 kilohertz filter is in accordance to each other. In last figure, you can easily see that we demonstrated two different range of low pass filter circuits. Mean to say, we demonstrated lowest value of cutoff frequency as 150 hertz with the 600 kilohertz frequency as the other side of the I mean to say the highest value of cutoff frequency, as we say that we are demonstrating the low pass filter circuits from a range of 100 hertz to 2 megahertz. So in this from this figure, you can easily conclude that using the resistors and the capacitors of a wide range as resistance from 4 kilo ohms to mega ohms, and the capacitors from 2 picofarads to 10 microfarads. We can easily fabricate low pass filters from 100 hertz to 2 megahertz. In conclusion, we can easily say that our we explored the practicability of pencil and paper based low cost and solvent free fabricated passive components and circuits as filter circuits. Also our fabricated components and the circuits are low cost and solvent free fabricated. Thank you very much.